Let's now move on to the next problem. Problem number 19. This problem states that a beam of unpolarized light of intensity I naught falls on a system of 4 identical linear polarizers. So let me draw the configuration. There are 4 linear polarizers. There are 4 linear polarizers. And a beam of unpolarized light, I naught, is falling over it. The transmission axis of any two successive polarizers make an angle of 30 degrees with respect to each other. It says that the transmission axis of any two successive polarizers make an angle of 30 degrees with respect to each other. So this angle is 30 degrees, followed by this is further 30 degrees, and similarly for the fourth polarizer. Let's call these polarizers, let's denote them as 1, 2, 3, 4, and we'll denote the corresponding intensities as I1, I2, I3, and the final output intensity as I4. And we need to find I4 in terms of I0. So we need the ratio. They're calling it D, calling it I, so I over I0. We need to find I0. And see, let's reason step by step. If this is I0, after passing through the first polarizer, you see this is unpolarized light. This light is unpolarized. So when this axis, when basically it doesn't matter how you orient it. So in that case, I1 is simply I0 by 2. Why I0 by 2? And basically the average over cos squared theta. Of course, the formula that we are employing here is Malus law. I equals to I0 cos squared theta. This is what we're employing here. This is our well-known Malus law. But if you see that for the first polarizer, theta, there is nothing to orient this axis about. So instead we have to basically take the average over one full cycle of cos squared theta, and that gives you half. So I1 is I0 by 2. Now we come to the interesting part of I2. I2 is I1 cos squared theta. Now this is 30 degrees. I0 by 2, and cos squared theta, cos squared 30 is about root 3 by 2 whole squared, and it's about 3 I0. This is 4, and this is 8. This is 8. Yep, looks right. Followed by I3. I3 is again I0 over cos squared theta. I0 over cos squared theta, and that would be 3 I0 by 8 cos 30 whole squared, which is again the root 3 by 2 whole squared, and that would give me 3 times root 3 whole squared. That's 3 times 3, that's 9. 9 I0, right? 2 squared is 4, and this is 32. And if we proceed in this manner, I4, which is our I, would be I3 cos squared theta. That would be something around 9 I naught by 32 times square root of 3 by 2 whole squared. And that would be 9 times square root of 3 whole squared, that's 3, so 9 times 3 is 27. And this would be 2 squared 4, and 32 times 4 would be 128. So our final ratio of I by I naught is 27 over 128. That is our option D. So that's about it. The final ratio, the final intensity is about 27 over 128 times the initial intensity. And let me just go through the reasoning again. You see the first polarizer. The first polarizer sees an unpolarized light. So cos squared theta used to be actually averaged over one full cycle, because there is no other polarizer to orient its axis with. It just sees unpolarized light, for which theta can be anything between 0 and 180. And after that, the other polarizers are all aligned at 30 degrees with respect to the polarizer before it. So in that case, we can simply plug in theta equals to 30 degrees in Mull's law and just keep on basically multiplying with cos squared 30 degrees and proceed. So I hope that was clear, and that would conclude our problem number 19. Let us move on to the next problem of the paper.